Father, we thank you for the privilege of gathering together, Father, to learn more about you as we've been learning through this process about who you are, Father, through your creation and just the power and might of the God that we serve. Father, we ask you to be with us during this time, that we learn things that are insightful to us, Father, that allow us to be better ambassadors and representatives of you as we seek to share the gospel and seek to relate who you are to those who need to know who you are. Father, I thank you for each one here. Father, I thank you for the week that we've had. Father, I just pray that you are guide and are with us during this time. We pray in your son's name. Amen. All right. So let me get the sharing option set up here. And anybody remember what we talked about last week before we start the video for this week?
The flood.
Talked about the flood. Was there more than one? We use the term the flood as if we have to specify it.
Oh,
There's lots of
I
floods
remember.
and different beliefs. At least there is a flood event pretty universally in other, I don't know, are they faiths or are they?
In other, I'll just call them in other religious beliefs and belief systems. A flood is a very common global thing in many of those systems. Native American, Mesopotamian, so what we think of today as the Middle East or the Far East as well. So today, you can see by what's cued there on the screen, I'm going to pick that up with the quick. We looked before, remember they looked before at some of the sort of the fossil record. They spent a little bit of time showing that. Talked about the flood and how, remember the main thing last week was around the difference between, I remember the two words?
Uniformitarianism and catastrophism.
Yeah, or
Catastrophism.
cataclysm. Uniformitarianism, that one I can pronounce, means that is the general belief that pretty much things progress and are the same as they've always been. So that's where the uniformity comes from. The idea around catastrophism or that type of thing is around that there were these major events that could do things in a short period of time. And you remember the point that they had made was that the flood represents a catastrophic event that explains a lot of things perhaps better than uniformitarianism does in terms of how long it takes for processes to happen. So that naturally flows into where we are for this installment, because this raises the question of how old is the Earth. So we'll get that rolling here. Let me know when you guys can see and hear. And we'll start it that first, and then I'm going to start.
Have you ever asked yourself, what was here before?
You hear it?
What was Earth like before I existed? What people, what animals have moved through the same space I'm in now? How long has everything been here? Just how old is this place we call home?
You guys can hear it, right?
Yes.
yes. Yes.
Thank you.
Hi, I'm Marcus Lloyd, and welcome to Unlocking the Mysteries of Genesis. In this series, we've been looking at the first book of the Bible and finding there's more truth in it than we may have thought. Today, we're going to explore what Genesis says about the age of Earth and see how it stacks up to the scientific evidence. When we ask, how old is Earth? We're really asking a history question. What is our planet's history? How long has it been here? How was it formed? Unfortunately, no human being was around to see it happen. The best we can do is look at clues and test them with modern science and technology and draw conclusions based on the results. All scientists work with the same data or evidence, the same chemical, biological, and physical clues. They find information in fossils embedded in geologic formations like this trilobite embedded in shale. They also examine current processes that impact our Earth, like sedimentation, erosion, and plate movements. For example, the scientists know that many parts of the continents are covered by geologic strata, layers of rock stacked one on top of another, like these books, building up over time. They also learn from studying natural processes, such as the rate of decay in organic substances like plants and animals. And they can learn by studying the written records of ancient civilizations. These clues are available for all of us. The key is how we interpret the information we get from them. So, how old is the Earth? Let's look at the data and see how both secular and creation scientists interpret them. But instead of talking about it, how about a little field trip? A trip back in time.
To the North Pole.
Our journey takes us all the way back to the beginning, to the creation. But how far back was that? How long will it take us to get there? I'll tell you what, I'm definitely packing a lunch. The age of Earth is a fundamental question, and to find the answers, we turn to both science and the Bible. In both cases, faith comes into play. Let's take a look at some of the methods that scientists use to estimate Earth's age. Age is not something that's always determined exactly. For instance, without your birth certificate or the testimony of your parents, how do you even know your own age, let alone someone else's? All scientists start with certain assumptions about the past, and then use faith in those assumptions, together with geology, physics, and chemistry, to make certain calculations about the planet's age, or more specifically, Earth's rocks. This is called geochronology. Now, there are several different ways to do this, and we sometimes get different results. The clocks that scientists use to estimate the age of rocks have things in common. They all assume, by faith, a constant process rate, like the sand in this hourglass. We assume that will always fall at a constant rate. And next, you need to have what's called a closed process system, like this glass. Nothing getting in there to interfere with the measurements. And finally, scientists have to begin with a known process component. Again, like the sand. You know how much you start with, so you know how much time passes as it falls. Did you get all that? A constant process rate, a closed process system, and a known initial process component. Simply speaking, if you know how much sand you have, and you know how fast it falls, and you know that it always falls at a constant rate, then you can calculate the time. But we'll talk more about that later. Well, now it's time to get going. Are you ready for an adventure? Let's explore the Grand Canyon for clues about the age of the Earth. We come to the Grand Canyon because it's almost as if the Earth has been cut open for us. This is the perfect place to see a cross-section of time. The strata in the walls of the Grand Canyon show the Earth's layers, one stacked on top of the other. The more recent layers on top and the older material below. And the deeper we go into the canyon, the further we go back in time. But how long did it take for all of this to build up? When was the first strata formed? Let's ask an expert.
Secular scientists say with great confidence that the rocks in the Grand Canyon are in the inner gorge more than 1 billion years old, and these layered sediments between 270 and 540 million years old. They base these estimates on the decay of radioactive elements like uranium and their measurements of how fast uranium decays into lead and helium in the laboratory. These scientists assume that the rate they measure in the laboratory today has been constant since the Earth came into existence. However, about 10 years ago, some of my colleagues and myself found powerful evidence that the rate that uranium decays has not been constant in the Earth's past, but has been as much as 1 billion times higher than we measure it to be today. This has profound implications. It means that this assumption that the secular scientists have been using for the last 100 years is wrong. The implication for the rocks in the Grand Canyon is that these rocks are not hundreds of millions of years old, but only thousands of years old. But what about carbon-14, the method that most people are familiar with? Well, first of all, carbon-14 is used to date the remains of dead plants and animals and not rocks directly. Carbon is present in every living thing. Carbon has 3 isotopes. Carbon-12 and carbon-13 are stable, but carbon-14 is radioactive. Carbon-14 decays into nitrogen-14 with a half-life of about 5,730 years, meaning half of it will disappear in that time. Plants take in atmospheric carbon. Animals eat the plants, and this introduces carbon-14 into their bodies. As long as the organism lives, it replenishes the amount of carbon-14 in its body, and the ratio of carbon-14 to carbon-12 remains constant. After the plant or animal dies, the carbon-14 in its cells decays back to nitrogen without being replaced, while the carbon-12 and a tiny amount of carbon-13 remains. The amount of carbon-14 as compared to the total amount of carbon in an organism will yield a calculated time since the organism stopped absorbing carbon-14. This age estimate is the calculated time since the organism's death and thus the calculated approximate age of the specimen. But an astonishing discovery, this time made by the secular scientific community over the last 30 years, is that carbon-14 is routinely found at significant levels in fossils that are supposedly tens to hundreds of millions of years old. But compared to those timescales, C14 is like a flash in the pan. There should be no carbon-14 detectable in any living thing older than 100,000 years, or 1/10 of a million years. What this implies is that all fossils are not millions of years old, but only thousands. And all the sediment-bearing layers of rock are only thousands of years old and not millions, including these we see in the Grand Canyon. And this implies that the Grand Canyon almost certainly has to be the product of the year-long Genesis flood just a few thousand years ago.
The secular dates of these rocks depend on one thing: uniformitarianism. Has everything always happened at a uniform rate? Has sand always fallen at a constant speed, like the second hand of a clock, steadily tick, tick, ticking? Or has it sometimes gone very fast? If it hasn't been constant, well, that's a huge problem for the uniformitarian outlook. Scientists have found soft tissue as well as DNA in fossils, but we know both soft tissue and DNA degrade within hours after death, and certainly after years and centuries. So why do they still show up in fossils that are supposedly millions of years old? Don't worry, we'll get to the bottom of this. To find some answers, let's head deeper into the canyon, closer to the beginning. The prevailing theory is that the Grand Canyon was carved by the Colorado River over millions of years. But let's look at another hypothesis. What if all this didn't happen over millions of years? What if these strata were formed suddenly, catastrophically, like when a volcano blows?
The idea that sediment layers can form quickly was documented in a dramatic way in 1980 with the eruption of Mount St. Helens. The initial blast was a horizontally directed steam explosion with the power of 20 1-megaton bombs that flattened in seconds 230 square miles of lush conifer forest. Following that, there was 9 hours of eruption of mostly vertical ash driven by steam, that much of which fell down vertically back to the ground and resulted in a horizontal pyroclastic flow, hot volcanic ash flowing at roughly 100 miles an hour. This material formed orderly layers of material, just sediment layers, some just a fraction of an inch thick. And you had tens of feet, hundreds of feet thickness of this material, demonstrated very clearly how rapidly ordered layered sediments can form. Moreover, a single mud flow following the eruption resulted in the carving of a canyon, 1/40th the scale of the Grand Canyon, in one afternoon through this layered debris. So it also demonstrated that canyons can be cut very rapidly, within hours.
So maybe there are flaws in the ways that scientists calculate the age of things. If you go to practically any museum of natural history, they'll tell you that dinosaur fossils are tens of millions of years old. But how can they be sure?
The contradiction, though, is that you have these specimens, coal, wood, even dinosaur bones, that are supposed to be tens or even hundreds of millions of years old, and yet there's still detectable carbon-14 in them. And that just should not be the case. And we think this is illustrating that one of the key assumptions of the method is wrong, the assumption that the decay rates have been constant. Because if you assume that the decay rates have been constant throughout Earth history, you will get millions and billions of years for those dates. But that very assumption leads to a contradiction. If the decay rates have been constant throughout history, then those fossils really are millions of years old, and there should not be any carbon-14 in them, or at least none that we can detect. But there is. And so that's telling us, we think, that there's a problem with the method. Another indication that there's something wrong with the method involves these little crystals called zircons that we find in granite. And within the zircons, you have uranium-238, which is radioactive. And it goes through this multi-step process where that uranium-238 is transformed into lead, a particular isotope of lead. Now, if you look, for instance, at the amount of lead in the zircons, you can figure out how many years of decay that would be at today's rates. And it's about 1.5 billion years. So if you're looking at the lead in the zircons, you would conclude that it's about 1.5 billion years old. But there's another decay product that occurs in this process, and that's helium. When the uranium turns into lead, you have helium nuclei being produced, basically helium atoms minus the electrons. And so they eventually, along the way, they're going to pick up a couple of electrons and they will become full-blown helium atoms. Well, these helium atoms, they don't react very well with other substances, and it's very easy for it to leak out of the zircons. If these zircons really are 1.5 billion years old, why is it that we still see large amounts of helium within the zircons? Because if they're really 1.5 billion years old, most of that helium should have leaked out. So here we have a contradiction within a single method. You have two decay products. You've got lead, you've got helium, and they're giving you two different ages for the zircon. And again, how do you resolve that paradox? Well, one way to resolve it would be if the decay rates have changed in the past.
Because of the types of rocks and fossils found in these layers, experts used to think that it took millions of years for these canyons to form. Now some have come to believe in a catastrophic theory of formation that says it all happened very quickly, violently, like from a global flood. Now I told you that we'd get to the bottom of these mysteries, and I think that we have. And the answers lie just below our feet and stretch out for hundreds of miles in every direction.
The lowest horizontal lying sediment layer in the Grand Canyon is known as the Tapete Sandstone. From the south rim, one can trace this layer from one horizon to the other. It occurs not just here at the Grand Canyon, but this Tapete Sandstone layer and its equivalents cover a large part of North America. The erosional boundary just below the Tapete Sandstone is commonly known as the Great Unconformity. It's an erosional discontinuity, beveled off the rock beneath it before the Tapete Sandstone was laid down. Just above that boundary, in the lower part of the Tapete Sandstone, we find large boulders. There's one boulder 15 feet in diameter weighing 200 tons in the lower part of the Tapete Sandstone. It boggles the mind to imagine a water process, moving water, able to rip up boulders that large, roll them along, round off the edges, and deposit them in a big layer of boulders, and do it all over the North American continent. So this leads creation scientists like myself to conclude that this must mark the onset of the Genesis flood.
So the evidence suggests that the different strata might have been laid down in a much shorter period of time than we thought. If the rate of change in the Earth wasn't constant, and if these strata didn't form slowly over millions of years, then the assumptions we've been using for our age estimates aren't reliable. And that means that our planet is much younger than secular scientists say that it is. Let's see what the Bible has to say. In Exodus 20:11, we read, "For in 6 days the Lord made the heavens and the earth, the sea and all that is in them, and rested the seventh day." That's an important point. Again, in Exodus 31:16 through 17, God says, "Therefore the children of Israel shall keep the Sabbath. For in 6 days the Lord made the heavens and the earth, and on the seventh day he rested and was refreshed." But what is a day? Can't God define day however he wants? A day being a day, or a day being a million years? The Bible gives us some clues. In Genesis 1, 4, and 5, God gives us his definition of day. God divided the light from the darkness. God called the light day, and the darkness he called night. So the evening and the morning were the first day. We can also work backwards to determine an approximate age of the earth by using the historical events described in Genesis, and learn how we became many people and how we formed many nations. So the Lord scattered them abroad from there over the face of all the earth. As we'll see in future episodes, modern archaeology combined with history matches up with the biblical accounts. And we know from historical evidence where the nations were. So now our Bible is becoming our history book, our earth clock. We'll also explore this question of day from an astronomical perspective, and we'll see how distant starlight supports the theory of a young universe. Now, many of you are probably asking, why do I need to know this? Why does it matter whether Earth was created billions of years ago or only thousands? What difference does the time make? It matters because of this. If the Bible is wrong or misleading about time in its very first chapters, where else was it wrong? If God was just being metaphorical in the beginning, then how are we supposed to know when the Bible is being true or when it's just being literary? Are we just supposed to pick which parts of the Bible we want to believe? How do we know that creation happened the way the Bible said it did? If it's all just random chance, if life was just a happy accident, a fluke, then the biblical scriptures have no meaning. But just take a look around you. All of this was not created out of chaos. For God is not the author of confusion, but of peace. And now the beginning leads us to the end of this journey anyway. And we didn't have to go back billions of years either. The evidence we uncovered today suggests that the dating methods that most scientists have been using are flawed, and that the age of the Earth may be counted in thousands rather than millions of years. This matters because knowing that there's scientific evidence that backs up what we know in our hearts to be true strengthens our faith. And this matters because knowing how we got here helps us understand who we are, why we're here, and how we should live our lives. I'm Marcus Lloyd. Thanks for joining me in this episode. In our next show, we'll take a closer look at dinosaurs because they raise big questions about faith. For a long time, scientists believed that these creatures roamed the planet tens of millions of years ago. But modern technology is leading us to question these findings. Why is it important that we get accurate information on the age of dinosaurs? We'll come back and we'll look closer into this and other mysteries contained in the book of Genesis.
Hey guys, there's going to be a test on that carbon 14 breaking down into nitrogen 14. So I just wanted to give y'all a little warning. I hope you were taking notes.
That's funny.
Lori just said everything without saying anything. So,
Sorry.
I was going to, but I couldn't find my pencil fast enough.
Yeah, that was a little bit, chemistry was not my strongest science. Biology, anatomy, physiology, those were definitely my stronger sciences. I mean, I certainly know some chemistry, but
chemistry was my stronger science. Does everybody understand generally how carbon 14 dating works?
I didn't even know there was such a thing as chemistry when I was in high school.
Oh, Diana.
Sherry could vouch for that.
Well, no.
Okay, I'm turning my mute back on.
My brain is void of carbon 14.
Ah, if that's the case, that means you're not a living organism, or at least you're a decaying organism.
I'm brain dead.
Yeah. Without getting too much into the science, but just to make sure that we're there so you can follow what they talked about there. I thought the use of the hourglasses is a very good visual way, to see the passage of time moving at different rates. You certainly saw when he had the red one and the blue one that obviously had different size holes in the middle, so that's what causes the same amount of sand to move at a different pace. That was pretty easy to pick up. But the half-life of an element is how long scientists believe it takes for half of the radioactivity to disappear. And so if you know the half-lives, which again are assumed to be constant, and you know what you would expect and what you have, it's then not just simple math, but it's relatively simple math to then do a calculation of how much time has passed, because as he was talking about, at what rate things are supposed to go away. So if I told you that I'll use this as an example, my mother-in-law's 2-week pill box had 14 slots, and that the pills go away 1 slot a day, and you saw that there were 3 slots left that still had pills from the original 7, the AM PM thing, how many days would you assume have elapsed since that was filled up? Assuming that she's good about doing it, putting them in and then taking them out every day. It's been 4 days, right? Started with 7, there's 3 left. They disappear at 1 a day. Pretty easy to figure out, well, it's been 4 days since that was refilled, right?
Yes.
But what happens if a particular day she happens to forget, and again, let's assume this pill box, maybe it's a bad example, doesn't have the little days of the week label across the top. It's just got day 1 through day 7 or whatever it is. What happens if she accidentally forgets to take a day? What does it do to the calculation that I just did?
alters it.
Distorts it.
Messed it up, right? If she forgot a day, then maybe it's been 5. Maybe it's been 6. Maybe it's been a year. And of course, if she were to accidentally double up,
What I was going to say.
then maybe instead of it being 4, it's actually only been 3. Get the idea that knowing that uniform rate and that there's consistency to it makes a difference in that calculation. So that's what's going on with carbon-14 dating, is the half-life of carbon-14 is a known quantity of around 5,000-ish years. I actually had it on the screen there, other 5,000
It's like
something.
5,600,
Yeah.
5760, I think is what's it.
Yeah, I was gonna say 57, 30 or 60. I know it ends in a divisible by
Oh,
3.
Cesar
kind of
said
thing.
30.
Yeah, divisible by 3 thing. Or looks like it is. So what they do there is they calculate, as he talked about, carbon-14, which is there's 3 types of carbon. Carbon-12 is the normal carbon because it has 6 protons, 6 neutrons. So carbon is the 6th element, and so it has that's its atomic number, the number of protons. But then there's one that has an extra neutron, that's carbon-13, and there's one that has 2 extra neutrons, which is carbon-14, which is what makes it unstable. And so that's the one that decays over time because it loses that electron, actually then eventually loses a proton, gains a proton and becomes nitrogen. So scientists, when you hear carbon-14 dating, what they're saying is they're looking at that decay rate of the amount of carbon-14 they would expect to find relative to the other amounts of carbon which don't decay, and they're calculating basically a percentage, and they convert that percentage into a dating, which is why that's always approximate. When you hear carbon-14 dating, it's approximately something because it's not exact. It's measured there in thousands of years for the half-life, not in days or weeks or months. And the other thing is, the key thing is this only works for living organisms that are taking carbon in. You cannot carbon-14 date a rock.
Mhm.
In theory, you can carbon-14 date wood that's been buried underground. You might even be able to argue you can carbon-14 date maybe petrified wood in the sense of it's been altered in some way, but it's only possible to do carbon-14 dating on living things. Does that make sense?
Yes.
So at one point there, he was talking about they use a similar process where they look at the amount of uranium, trace uranium that's in rocks, which they also know what the decay rate is. And so one of the things he said early on was they had discovered or were recognizing inconsistencies between essentially the numbers they get when they look at the rock and the numbers they get when they look at other things like carbon-14 dating for newer formed rock. And so that's one of the things that causes this into question. And then again, they use the Mount St. Helens example of a catastrophic event that was not only witnessed, but was witnessed in very recent history. That was 1980. And witnessed in an area that was very visible. This wasn't some remote island in the Pacific. This was in the Pacific Northwest of the United States, and not a populated enough area where you saw there was film of the actual eruption because it had been building over time and geologists were there to study that. So not that I can answer all of them or any of them, but are there any questions sort of about what the science they were talking about in terms of how they date, how secular scientists date things, how old things are? So
You know
go ahead.
you know the names of the scientists that secular scientists they spoke of that contend that it's not constant. That would be interesting to see who they are, what their degree is, and what kind of research they've done.
You mean the ones that are not part of creation science movement, that are essentially that they would not be in the scientific community considered to be tainted because they aren't in that camp?
Correct.
Yeah, I don't know who those are. I'm sure if you go to Answers in Genesis or the Creation Research Institute, who actually produces this series, you probably
Okay.
will find a lot of references for that.
Good. Okay.
So he asked the question late there at the end, which, this is seeking the application for why we're even doing this. Why does it matter?
Because the way the secular scientists describe the Earth and the creation or how things went was a much longer time than what's depicted in the Bible. And we're trying to, do you believe the Bible or do you believe just human scientists?
Right. And for example, the argument that's made for evolution, which they've already covered and talked about, what does that require more than any other element?
Time.
And not just little bits of time. It requires exceptionally long periods of time measured in, they start using terms like eons and epochs to describe them. When you start putting a bunch of zeros, it's hard for me to imagine a million years.
Mm-hmm.
I struggle with sometimes imagining 1,000 years, a millennium, or even a couple of thousand years. It's hard to imagine that with, a million is 1,000 thousands.
Mm-hmm.
So, I can sort of think in my head, 1022. Okay, that's almost to 10, one of the dates that sticks out for me in history is 1066. That's the Battle of Hastings, the conquest of England. I sort of can place that in the big historical record for me. That was about a millennia ago. That was 1,000 years. Imagine now 1,000 times further back when you're talking about a million years. And you start talking about these eras that are 50, 60, 70 million years, just trying to put it in context for the time that's there. So if you've only got an Earth that's roughly 6,000 years old versus an Earth that's 60 million years old, what does that do to one of the things that they talked about earlier? Well, it takes out the underpinning for even the concept of anything that looks like evolution to happen, because it requires a lot of zeros in whatever you're describing the years to be.
Puts doubt in your mind in reference to the theory of evolution.
Right. Which has other problems that they've already expressed and covered as well. The idea of, when we talked about, irreducible complexity. So you have three things that have to evolve simultaneously because they depend upon each other. The two without the other one, or the one without the other two, doesn't make any sense. I think that's a bigger challenge versus the time question to evolution. But you definitely have the additional challenge to those who want to hold to the theory of evolution, in the sense of, if you don't have enough time, even if you believe that can happen, you don't have enough time for it to happen.
And I've heard recently they've determined that the Earth's core is cooling faster than initially thought. That would help, if that's true, that would help negate the billions of years theory too.
Yeah. Well, and then there's the question of, background radiation in the universe, the speed at which items in the universe appear to be moving. Are they accelerating, decelerating? There's a lot of stuff there. The astronomy that goes on. I took 6 hours of astronomy in college. I remember a little of that. Of course, it's been in the news in a big way recently because of the launch of the latest, the Webb telescope, the one that's made its way out to the Lagrange point and is now setting up for the whole purpose of that telescope was it's able to look further into the universe. When you look further into the universe, because of the fact that it takes time for light to travel, when you look up at the sky at night, when you look anywhere, you're looking through time because it takes time for images to get there. But when you look up at the sky at night and you see stars, you're actually looking back in time. And so the question is, how far back in time can you look, or can you see? And they're hopeful that telescope's resolution and what it's looking for is going to enable them to look further, quote unquote, further back in time than they've ever been able to look, because it's going to be able to pick up fainter signals from further away. Further away means farther back. But again, there's an assumption going on there that they referenced in the video here, which is that everything that they're using to measure that all of, Sherry will appreciate this, someone who is more mathematically inclined than I are, that there are more constants in the equation than there are variables, right? If you want to solve an equation, Sherry, you're solving for the variable, right?
One more time, could you repeat that?
when you're solving an equation, you're normally solving for the thing that's expressed as a variable, right? What is X?
Yes.
Is it more challenging and more complicated to solve an equation that has multiple variables?
Oh,
Certainly.
absolutely. Yeah.
In fact, what do you have to do to solve that equation most of the time?
Make one of the variables.
Well, if they're linear,
Class A computer.
oh shoot, if it's a linear equation, however many variables you have to have that many equations to solve that system.
Right.
So if you have three equations, I'm talking about a linear situation. If you're talking about three equations, three variables, you have to have three equations. If you have 100 variables, you have to have 100 equations to solve it.
And I remember what little I remember of algebra, which is just enough to be dangerous. Part of the way you did that at some point was, didn't you assume that one of the variables was a constant?
No,
No.
you can do it by elimination, substitution,
Okay.
matrices, matrix operations.
But the more variables you have, the more complicated the system is, right? You said that's how many
Yes.
equations you need to solve it.
Yes.
And if something you think is a constant suddenly becomes a variable, what did that do to all your math?
Oh, it changed it. If anything changes, it changes everything.
Right. And so
Makes it new
again,
math.
yeah, yeah. So if you change anything that you believe to be a constant in these scientific calculations, that also has a tremendous impact. Why? Because it changes the math. It changes what you thought. And we all know that if you change something over here, the ripple effect of that is it changes something over there. And once it changes that changes something else. You know, ripples through these, you use the term systems of equations there. Sherry, this ripples through the systems. This ripples through the theories that you've built because one relies upon the other and they all connect together.
Mm-hmm.
I took just enough physics in high school and to be dangerous, but probably the most famous equation in physics probably in the last century is what?
E equals
MC
mc squared.
Yeah, which is, we think of that being associated with Einstein. We think of that being associated with the rise of atomic energy, with theories of relativity. He got to E equals mc squared, as I understand it, by what? By combining and putting together and doing the high order math on a lot of other equations. To show you that E equals, in this case, mass times the speed of light squared, comes from putting together other equations to get to that conclusion. If you alter any of those base equations that led to that, you would come up with something different than E equals mc squared. In fact, that C is I think they're going to get into this. I haven't looked ahead at that episode, but that C is very important. That C represents what?
Speed of
light, which we assume is what?
Oh, shoot.
constant.
It's a constant.
Right.
Yeah.
That light always moves, always does move now, which when we observe it, we pretty much see it act as a constant, but that it has always moved at the same speed that it's always been that. And I know that's one of the things they're going to get into and discuss a little bit.
Because black holes, if there are, then that disprove that?
Things get really weird around black holes. For example, things get really weird when you start traveling towards, we also tend to think of the speed of light as being the universe's speed limit. That's how it was always described to me in terms of the simpler forms of physics. You can't go faster than light that we know of, unless it's, unless it's science fiction. That's how you get to go faster than light. And part of the reason for that is they do know about this thing. In fact, Einstein theorized this, and they've done experiments to prove it, which is the fact that as you move closer, as you move faster, what happens to what we perceive as time?
It
Slows down.
slows down.
Slows down. In theory, being such that as you approach the speed of light, it grows slower and slower to the point that if you reach the speed of light, for all intents and purposes, time for you would, as we
Stop.
experience it, would stop. And that, that's as far as I'm going to go with that, because that very concept in and of itself messes with my head. But around black holes, you get this distortive effect because of the interaction between mass and gravity. The mass is so tremendous that light can't escape it, so it changes and alters the perception of time, which is just, again, that's I like to think I have a pretty good mind in terms of being able to grasp most things, but I lose the ability to grasp that unless somebody breaks it down for me in a very simple way really quick.
So if you go faster than the speed of light, could you go back? Because you can't have negative, I mean, that would negative time. There's no such thing as negative time.
Well, there's, we talked about this before. There's even how, in fact, we talked about this a lot. We talked about the attributes of God. We perceive time the way we perceive time. I believe that God sits outside of time. And I don't even, when I say that, I don't even understand how to explain that. I don't even understand what that means.
Well, I think the thing that in my head I struggle with is that I get the reason why thinking of the earth as only 6,000 years old is kind of important for like the whole theory of evolution versus creation and stuff like that. But God still existed before 6,000 years ago. If I believe that God is eternal, then he existed 700 billion years ago. So I guess it makes you think, so why did he create when he did? What was he doing prior to creating the earth? What's he going to do? That eternity thing that then you have to kind of grapple with. I don't know if I'm explaining it right, but he being outside of time was still existing prior to making the earth.
I've said this before, if it makes any sense. I keep thinking about the desks I had in elementary school that they put a number line. Anybody else have the number line that was across the top of the desk? You know what I'm talking
No.
about?
No.
Basically looked like a ruler on tape where they had put like, it was this was like, early elementary was to help, understand subtraction, addition. I don't struggle at all with infinity moving forward. The +1, I can get my head around pretty well. I can always imagine, okay, that number and add 1 to it. The moving forward, if you will, on the number line, which is how I think of time as a line, a timeline, the plus part, moving out and it doesn't have an end going towards the right, I don't struggle with. It's when I try to go in the opposite direction, the -1 direction, okay, and before that, something has to have a start, right? Except that we believe that God is eternal, that eternal works in both directions. And that's what starts to hurt my head. Other thoughts, questions?
Well,
Yeah, I was just curious. I was looking at the rate of decay equation, and basically it's an exponential equation. So, carbon 14 starts out, it's all there when something dies, but then it decays at an exponential rate. And so the half-life is 5,700 years. But when you get out to like 50,000, 100,000, that curve approaches zero. And, an exponential curve theoretically never touches zero, but it's almost zero. And it's a horizontal line from that point. So, how do you tell the difference in 100,000 years and 1,000,000 years?
As you point out, I'm actually going to try to pull up. I pulled this up on the screen so that everybody can sort of see if I can get the right one opened up.
Well, if you zoom in, it's not a horizontal line, Bill. The closer you zoom into the y-axis, it's not a horizontal line.
That's true, but
But to your point, Bill, you reach a point where the small percentages, because of the exponential nature of the equation, the small percentages in difference are tremendously long periods of time.
right.
I don't know how well I
And do
can.
they have scientific instruments that can measure with that kind of precision?
Well, and then you begin to wonder about the quality of your sample and all kinds of other things that
Exactly.
that come into that. Is how reliable is your baseline? And here's just so everybody can sort of see what we're talking about here. Can you guys now see that? Probably
No.
helps if I click
Not
share.
yet.
Here it comes. But here's the chart that shows, 100% of the carbon-14, the percentages going down, and then how, again, this is the curve of that. It's not a linear equation. That's referenced by the fact that there's an exponential curve in there. But notice how that's 5,700 years. That's 11,000 years. That's 17,000 years. This doesn't even show it out as far as it can go. But as you get down here, it goes way out really quick.
I guess my deal is, we know time is linear. As humans, we can understand time is linear. I guess there's so many other things in what we see now that isn't linear. So why would we just expect that the processes and the deteriorate? I mean, we just said, the decay of carbon-14 is exponential. I mean, I just don't understand why they just attribute that all the other decay, all the, the changes in the earth would basically be linear as well. Doesn't make sense. Do you understand what I'm saying? They're proving something that's kind of they're trying to prove that something's linear with something that's exponential. Does that make sense?
Mhm.
So
And you're saying that math sort of doesn't make sense, right?
no. Mm-mm.
Well, to me, the other interesting things about this is, if you think about evolution is the term that's been introduced here multiple times. Uniformitarianism is what? That things stay constant. Slow. What is the very heart of evolution? That things change. Which is, so I think sort of to your point there, Sherry, which is it? Is it about constancy, or is it about change? Because on the one side, you want to argue that things are very consistent and constant. And on the other side, you want to argue that things
Are changing.
change. Which is it? Well, the answer is depends on which side they're talking about. They want it to be both.
Well, there is such a thing as a constant rate of change, obviously.
That's correct.
But
That's correct. Acceleration is a constant rate of
constant rate
change.
of change.
That's
Which is
right.
different than velocity, which is, which can be constant, but is not changing.
Mm-hmm.
So where's the application for this? How do we apply it? I'll answer my own question and go with this, because again, you will see the documentaries that are on, channels left and right. You'll definitely run this into conversations that happen in the real world. I've had conversations with coworkers or with people I've encountered about, beliefs in this area. You certainly see, an ichthus on the back of a car. You'll see the little Darwin, whatever that is thing. Obviously that's someone who's saying that they believe in evolution over God. To me, the most important thing is for us to be able to give at least a reason to say, have you thought about, and being able to engage in the conversation that's not in a argumentative way, but that causes that person to at least think about, have you really looked at all the science? Because it's so easy to just go find, just like everything else in our society today, you can go and find things that reinforce what you already believe.
Not just the science, but the math. Sorry.
Leave the math out of this.
Sorry.
Anybody have any other questions or comments? I know we're getting close on time here, so. All right.
This is good.
Yeah,
I
good.
actually think the presenter is incredible. I was thinking he's incredibly gifted at what he does there.
Very good.
He may just be an actor reading a script, but he's good at taking that and emphasizing the right things. I'm
Right.
gonna go ahead and stop the recording so everybody can come out of hiding.